Another question we get a lot about transformers and fluid is startup procedures, how those change between fluids. Is there any difference?
When FR3 gets cold, it starts to crystallize. Obviously, if it's crystallized, the viscosity goes up. And there comes a point where the crystals are so dense that they don't flow anymore. And that point of FR3 is around minus 21 degrees Celsius. Any transformer that's going to be subjected to a cold start at minus 20 or below should go through a cold start procedure. If you just suddenly put load on a transformer, it'll sort of thermally shock the insulating system. The fundamental cold start procedure is the same for mineral oil transformers. It typically involves energizing the transformer with no load, holding it that way for several hours. The no load losses are usually enough to raise the oil temperature. Then the next part of the cold start procedure is to slowly add load, typically in about 25% increments, hold 25% load for a couple of hours, and then increase it another 25%. And that way you're slowly raising the temperature of everything. In the transformer, the heat is coming from the core and the coil assembly inside the tank, and it will migrate out and slowly melt that liquid from its crystal form back into the liquid form where it's flowing. Good thing about FR3, as I said, even in its crystal form, it maintains its dielectric strength. At cold temperatures, mineral oil becomes very weak dielectrically. The risk of a dielectric breakdown on cold start with a mineral oil filled transformer is much higher than with FR3 because the FR3 maintains its dielectric strength. But it is important to go through that procedure, make sure the liquid is flowing before any mechanical devices are operated, and know that the oil temperature is up at minus 10 degrees Celsius. Everything should be flowing, and there shouldn't be any concerns.